You had to pay them a lot sometimes. And we had to measure them often because most of the tests that we have for drinking only measure whether alcohol is in your system for a 24-hour period. So we had sporadic testing. We tested them about 4 times a week. We tested them every weekend day. And every time we tested them and they had not had anything to drink, they got some money. Actually, they got a chit for something that we gave them a gift certificate at the back end. That was based on parents' wishes that their children not be given free money at all times of the week. And what we found was, in the first week that we tested them, so they were on average abstinent for 10 days, that we could see a difference between these average high schoolers, matched in age, matched in gender, all the kinds of things I mentioned before, socioeconomic status, the grade they were in, the ethnic background, that the teens who binged about 10 days ago, their scores were significantly different, both on those verbal learning kinds of skills and on those visual, spatial, or nonverbal learning kinds of skills. The same kinds of pattern that we saw for alcohol-dependent youth. So what does this suggest? It suggests that youth who just binge drinking alone can have an impact on your ability to think, and I think your ability to perform in school. But you can see in both of these cases that once they have 3 weeks of abstinence or 5 weeks of abstinence, then they look normal again. But it may take that long to recover from the effects from the binge episode. So we think of alcohol as a normal product in our lives. People drink very regularly. But remember, teens binge drink when they drink. They don't have a drink or two like most of you did if you were at a reception beforehand. They would be drinking 5 drinks in that period of time. And this can impact people's performance in school. There are other ways that alcohol can affect us in our daily lives. We all see advertisements. So we did a study where we looked at alcohol cues, and we looked at teens who had heavy use versus those who did not. We had some pictures that were pictures of alcohol with and without social context, or their other favorite drink, non-alcoholic drink with and without social cues associated, and we matched these on color and intensity and the content and the valence, all this technical stuff that took forever. And in the end, what we found was that when we compared for each individual their reactivity while we were scanning them in the MRI machine, that youth who had a history of heavy drinking, even if they weren't drinking now, 3 weeks later, still had greater reactivity to the alcohol cues. So it can compared to youth who did not have a history of binge drinking. So they were all drinkers, but the ones that had binge drinking, their brains were responding in a much more forceful way, more active way when they saw alcohol cues. That tells us a little bit why it's so hard for youth after treatment not to drink or use. They see these cues and already their brains are having a stronger reaction than you or I would to those cues, even if we were regular drinkers. Well, you know, we know a lot more about alcohol's effects on the brain, but it tends not to come from human studies so far. It comes from animal studies, because in animal studies, we can sacrifice those adolescents, and we can cut their brains up, and then we can look and see what happens to their brains if they were exposed to alcohol during adolescence versus if they were not. So what we see in studies of mice and rats and pigeons, a variety of different animals, that compared to adults, if the adolescent animal was exposed to alcohol, adolescents are less sensitive to the effects of alcohol, the sedative effects of alcohol, but they're more sensitive, or they get more disruption in their memory, just like I was talking about with humans. There's poor transmission, neural transmission in the hippocampus and the cortex. Those are regions associated with learning and with memory. And that adolescents have a greater social activation under the influence of alcohol, actually, and other drugs. It also looks like, from animal studies, that binges produce long-lasting effects, and we can actually see in the tissue of the frontal lobes damage that's been done that's associated with alcohol. The other thing is that the longer they are exposed to the alcohol, regardless of the intensity, it exacerbates what are considered withdrawal symptoms in animals, and it can produce some long-term changes in the cortex and the hippocampus. So this gave us the sense that we really should understand better how adolescents deal with alcohol and drugs, how it impacts people as they're developing at different stages in their brain. And so the National Institute of Alcohol Abuse and Alcoholism led a group of 4 institutes from NIH and said, we want to have a consortium across the country to really study the effects of alcohol on neurodevelopment during adolescence. We had the good fortune of winning that award, and so I now coordinate what's called NCANDA, the National Consortium on Alcohol and Neurodevelopment in Adolescents. It's based in San Diego. We've got a data center up in Stanford, but we collect data from 5 different sites around the country, and this slide shows a lot of consultants and advisors that we have on the project. And CANDA is designed to look at a few, what I think are very important things. What are the effects of alcohol on neurodevelopment trajectories? Does it change the way the brain develops over time with development? What about the timing, the dose, the duration of alcohol's effects on the brain? Can we make those effects go away? Can abstinence alone make those effects go away? Do children's brains return to normal once you stop drinking and using? And then what are other factors that can influence those effects on the brain? If you have a family history of certain kinds of problems, if you have a history of trauma, if you have sleep problems, there are a whole variety of different things that might impact your functioning. We're looking at risk and protective factors, and we know that a lot of problems emerge in adolescence in conjunction with alcohol and drug involvement. And so we're looking at some mental health and physical health problems as well. And we're hoping that by studying these children from 5 different sites around the country, that we'll be able to figure out some new ways to prevent alcohol problems, better ways to treat alcohol problems should they unfold, and better understand who's at risk. I don't think I need to go over these. I'm gonna just share with you, though, a few of the kinds of data that we're gathering. For example, we're doing all sorts of cognitive tests with them, as you would expect, because that's what I study. But we're getting biological samples, saliva samples, so we can look at pubertal hormones, some epigenetics. We're doing alcohol and drug screens every time we see them. We're doing sleep studies, inhibition studies, and we have a recovery protocol where we're tracking these larger numbers of youth, like I showed you in my other study, where we paid kids to say alcohol-free. And one of the really cool things that we're doing is we're trying to use new technologies that make it easier for youth to participate with us, and where we can get information about them in their natural environment. So we have an app that they put on their phone when they come to the session to be tested on a once-a-year basis. And then we trigger them to download their app, remind them to download their app on a once-a-month basis, and they answer a series of questions. If they have started to drink or started to use substances, then we start asking them questions a little bit more often, on a weekly basis. We have them wear a Fitbit, and the Fitbit tells us about their activity levels, gives us heart rate in the natural environment, and actually we can get sleep-wake cycles for them by their wearing the Fitbit. The information from the Fitbit is downloaded to their phone and then to a master computer. And we're developing biosensors. The professor, I think I met some engineering students earlier in the evening, and this is for you engineering students, because my favorite professors at UCSD are nanobioengineers, and they're making unawarables. And these are things that you would put on, that you would wear, and after a time, you just not be aware that they were on. So we're having something made that's like a Band-Aid that you can put on and wear it for a week. And on the inside, it has these teeny little sensors. It feels like scratch paper when you put it on, but then it doesn't scratch after you put it on. They're actually micro needles. I don't like that term because I wouldn't want to wear some micro needles, but it's really what it is. And they have these the little sensors in it that are going to be able to tell us in real time when somebody's drinking and how much they're drinking. And it's because that little scratch gets the measurement component below the top layer of the skin, and we're actually measuring some chemical reactions that are produced based on alcohol in your system. And so this is going to be a really cool way for us. We won't even have to ask youth if how much alcohol they've had, because we will know it, and they will be unaware that they've reported it to us. Now, of course, they have to agree to participate in these kinds of things, and they know exactly what we're doing. But the idea is that over time, you get used to that, and you won't be paying attention. And then we don't have to worry about, bias in their reporting, and or are they embarrassed to tell us something? We will just know. So, yeah, these